What's going on, everyone? It's Jabril Muhammad back at it again with another in-home server build video, and today is day 4. It's pretty late today. Right now I am currently down at one of the data centers in St. Louis, Missouri, and just had to come and put some work in real quick. So I wanted to get back on track, and yesterday's video was about setting up Tailscale. It was a very simple setup, integration across all of our devices. We were able to do ping tests to communicate with each device so we know that we're connected. The next thing for me was that was a lot of progress. Now we need to learn about how to keep our devices on and what we're using to communicate with the devices. You know, that's an important step in this process. And I don't know why that just happened, but we'll go back into preview mode. And what we're going to start doing is recording videos from my computer. Once we get there, I kind of like these raw format videos because nobody's doing it. Everybody wants to be perfect. I understand it, but raw format is super cool. I can't mess up, and if I do mess up, you know it's real. I'm not editing anything. We're just doing this one shot. So when I was studying SSH and when I was studying, computer communication, we were able to land on a couple of things like HTTP, SSH, HTTPS, just basically how data is sent. And right now, Wake-on-LAN is something to where it allows us to power on a device, a server that's asleep. I instantly kind of ran into a bottleneck today. I was checking my Tailscale and I was looking at my connected devices, and I only had my server at home available for Wake for 1 hour. So this was a huge problem because now I can't access my server. This is how we figured that out, and this is how we solved that with SSH, with Wake-on-LAN. So Tailscale gave us secure SSH. Now we need to go into our BIOS and turn on this setting called Wake-on-LAN. What is Wake-on-LAN? Wake-on-LAN is a network standard that allows you to power on sleeping or shut down computers remotely. Even when a PC is off, a network card stays lightly powered. It's called trickle power, so it can listen for one specific signal, the magic packet. What is the magic packet? It's a tiny data frame sent over the local network containing 6 bytes of FFF, basically like a little code or whatever to allow it to know, hey, this is the correct code, address, thing. Boom, wake up to this particular thing or listen for this. Followed by the target's machine MAC address repeated 16 times. Only the NIC with the matching MAC address wakes the machine. Every other device on the network ignores it. What you need, and I'll zoom this in just a tiny bit. What you need, a motherboard with NIC that supports WOL, and that's nearly all modern boards. WL enable in the BIOS and UEFI. We'll go over that in page 4. WL enable in the OS network settings. We'll see that in page 5. We'll need to know the target machine's MAC address and that the devices are on the same network to send the packet. In my case, it's going to be a phone, a laptop, and a PC at home. Now, what's SSH? This is secure shell. This is once you wake your server, how do you actually get control of it? And SSH allows us to do that. SSH is a encrypted protocol for logging into remote's computer command line over a network. No monitor or keyboard is needed on the server itself. So essentially, I can log into my server at home from this computer right here, and nothing is needed at the computer at home to actually do anything with, because we can control it from this device. Why it matters here, WOL only turns on the machine, but SSH is how you log in afterward to run commands, check statuses, or manage those services. This works from anywhere on your network, remotely with the right setup, no cables, no extra monitor. Simple, secure connection. It's like sending a text message. So the traffic is encrypted, so credentials and commands aren't sent in plain text. And then it's always going to be this quick reference thing over here to show us kind of how to connect to it, what we need to know, and all that good information. So this is the basic connection command right here, which you would go into like a PowerShell or something and command line interface, terminal, and type this command in, or type the specific command in for your server and its IP address. Here is default porting, enable Ubuntu or Debian, that is Linux, and it tells you how to install that. Then you can enable on Windows 11, and you can see, boom, 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 goes to the settings, the apps, the optional features, and open SSH server. Check if it's running, and then there is another command right there to actually check if it's running on Linux that you can put in. It's called sudo systemctl status SSH, and we will be diving into Linux very, very soon. Now, how do we enable the Wake-on-LAN in our BIOS? We do that by rebooting our computer, and we enter into BIOS. For some people, they have to hit delete, F2, F10, or F12. It varies based on your motherboard. Typically me, I'm hitting F12 or F10 or F11 or spamming all of them at the same time because one of them is going to work. And then number 2, switching to advanced mode. Inside of BIOS, there is something called advanced mode, and what you're going to look for are 3 different potential things called power management, APM configuration, or ACPI configuration. Now we'll enable the WOL setting. Find Wake-on-LAN, resume by onboard LAN, or PEM event wake up, and set to enable. Then we're going to disable EUP ready. This deep power saving mode cuts power to the network card entirely, which blocks WOL. That must be disabled. So that is a very important part. Disable ERP. And then we're going to save and exit. We're going to save our settings now because we just changed things in our BIOS. We need to save those settings and reboot so it can reboot normally, and boom. And then they also have a tip for us. Menu names vary by manufacturer. You know, I got Asus, MSI, Gigabyte, ASRock, Dell, HP. If you can't find Wake-on-LAN, check under power or onboard devices. That can also be another source for you. And then last but not least, I think this may be the last one. Step 2, wake it up and log in. With BIOS set, finish, set up in the OS, then send the magic packet. You enabled the WOL in the OS. So this is like for Windows, you'll be able to go into Device Manager, Network Adapter, Power Management tab. Then you'll be able to check for if this device is allowed or not, but you need to check and make the device able to be allowed to this computer, I guess, to wake it up. That's what it's kind of saying. Then you set the wake on magic packet to be enabled. And then they also have the way that you would do it for Linux. So you would do it through the CLI or a terminal inside of Linux, and they got that special, code for you, or command, excuse me. And then we're going to send that magic packet. So from any device on the same network, we will use WOL app or a CLI tool with the server MAC address. For this step, I'm going to be using Codex or Claude to assist with that. And then also I'll do it manually because I think I need to do that first and figure it out. But yeah, you can use Mac or Linux CLI or use a phone app like Wake-on-LAN. I didn't know that was an actual phone app, so that's pretty cool. Then you're going to wait 15 to 30 seconds for that machine to boot, and then you'll connect to your secured shell connection. Boom, and now you're in. the server is awake and it's under your control. And that's basically it. That's what we learned today. So what I have to do when I go home is I'll end up setting this up on my BIOS for my server. And this was a pretty good informational packet of, you know, just the basics, I guess, of what SSH is. I can't say my S is really good. And what WOL is, Wake-on-LAN. And some people may get stuck at that step because, hey, it's like, okay, I set up my Tailscale, but my device won't stay on. And this is how you solve that problem. Persistent connection right here, always on device. The device has to be always on if you want a persistent agent as well. It needs to be in an environment where that environment is not determined by the device being on or off. So, I don't know if that made much sense. I mean, cloud services, that's basically, it does kind of make sense. So you got cloud services and things of that nature. Your device may be off, but if you're able to use a cloud service inside of an environment to keep that agent on, that's another way. Right now, since we're doing things locally, I have to make sure that my device can always be on, or it can wake up when I need it to, so we can always have that agent like Codex running. The problem with Codex and other agents is if the device is not on, they don't run. And that's what I'm trying to figure out and solve for, which is one of the reasons I bought in-home server. So this is the end of the video, guys. I know this one is a little bit later, but we'll keep going back to our format this week of uploading around 3 to 4 p.m. And I appreciate everyone as well. Bye.